Hello friend, the topic is parallelogram law of vector addition. I have made video on this topic earlier and today I am making an updated version of the video. Okay, the first one I should start the law. The law is, if there are two adjacent sides of a parallelogram taken from a common point representing two vectors in magnitude and direction, then the diagonal of the parallelogram taken from same common point will give the resultant of these two vectors in magnitude and direction. Let us suppose the vectors are P and Q with their proper orientation as well as magnitude. This is P vectors, this is Q vector. Okay, completing the parallelogram. So definitely this is the diagonal. If this P vector and this is Q vector, this sides of the parallelogram represents the P vector, this side of the parallelogram represents Q vector, and the diagonal represents resultant, then the resultant must be equal to P plus Q as per the law. Okay, so the next thing is we have to find out the value of R, magnitude of R. Let us suppose again the P and Q vector are inclined with each other at an angle theta. Okay, and if this angle is theta, so this angle will also be theta. Draw a perpendicular from this point on the line of the vector P produced. Let us suppose this point is A, this point is B, this point is C, this point is D, and this point is E. Okay, so here there is a triangle AEC. This is a right angle triangle. Of course this will be right angle because this angle is 90 degree. Okay, so this is the hypotenuse, this is the base AE, and this is the perpendicular C. We know a famous formula which is called Pythagoras formula, and which is equal to hypotenuse square, that is h square, is equal to perpendicular square plus base square. So we will use this formula. Okay, so before starting whichever I'm trying to find out the value of cos theta and sin theta. Here, what is cos theta? What is sin theta? In the triangle BCE, in triangle BCE, cos theta is equal to base by hypotenuse. In this triangle, the base is BE. Okay. Now what is hypotenuse? Hypotenuse is BC. Okay. Now on cross multiplication, we will get BE is equal to BC cos theta. Again, I would like to say that if this side is representing the Q vector, then this side will also represent the Q vector, because this line is parallel to this line and they have the same magnitude because their parallelogram opposite sides are equals. So this BC sides is actually Q. Okay, so this is Q. So here I can replace the BC by Q cos theta. One more thing I would like to say that here I am putting an arrow sign over it. It means that it is a vector quantity. It means that I am considering two things, magnitude as well as direction, but here there is no arrow sign over it, so I am considering only the magnitude. Okay, Next again I will try to find out the value of sin theta. What is sine theta? Now sine theta is equal to perpendicular by hypotenuse. The sides just opposite to angle theta is CE, and this is perpendicular. Okay, so CE divided by hypotenuse. Hypotenuse is BC. Again BC, we know very well, BC is equal to Q. So this will be equal to CE divided by Q sine theta, and on cross multiplication we will get CE is equal to Q sine theta. Okay, now next things. Next thing is in triangle ACE. In triangle ACE, what is AC? This is hypotenuse. What is A? This is the base. And what is C? This is the perpendicular. So here I am using the Pythagoras formula, that is h square is equal to perpendicular square plus base square. So it can be written like this one: AC square is equal to AE square plus CE square. Now again, what is AE square? AE can be resolved into two parts. AE consists of two parts. It can be written AB plus B. So here I am putting AB plus B in place of A. Now we know very well a formula A plus B square, which is A square plus B square plus 2AB. Similarly, I just expand it, so it will be like this one: AB square plus 2AB BE plus BE square plus CE square. Okay, now what is AB square? In the picture, AB square is just the P square, because AB is equal to P, considering only the magnitude portion. So here I can replace AB by P square. Now again AB, that is P. What is B? B, we have evaluated the value of B. B is equal to Q cos theta. So putting the value of B, Q cos theta plus. What is B square? B square, again we have evaluated the value of B. B is equal to Q cos theta. So it can be written like this one: Q square cos square theta. And what is C? C again is equal to Q sin theta. So this will be Q square sin square theta. Now, so on simplification, we will find that here this portion cos square theta plus sin square theta is a very known thing, that is its value is 1. So the expression reduces to P square plus 2PQ cos theta plus Q square. Okay, because this is equal to 1. So what is AC? What is AC? AC is just the value of R. So we can replace the AC by R, and as it is a square quantity, so I am putting in power 2. So R will be equal to P square plus 2PQ cos theta plus Q square to the power 1 by 2. So this is the value of R. This is the magnitude of R. And the second part is to find out the direction of the resultant. So let's start. Here again I am making an assumption that the resultant vector making an angle alpha with the P vector. Okay, resultant AC is making an angle alpha with the P vector. So if I am taking tan alpha relation in this triangle ACE. ACE. In triangle ACE, tan alpha is equal to perpendicular by base. Here the perpendicular is C, and what is base? Base is equal to AE. Now AE can be resolved into two parts. AE is equal to AB plus B. Okay. Now putting the value of C. What is the value of C? Here we have already evaluated the value of C. C is equal to Q sin theta. So putting the value of C. Now what is AB? AB is just a value of P. AB is just a P. So putting P in place of AB. And what is B? B is equal to Q cos theta. We have already found it. So here we are finding that tan alpha is equal to Q sin theta divided by P plus Q cos theta. So alpha is equal to tan inverse Q sin theta divided by P plus Q cos theta. Okay. So this is the magnitude of the resultant R, and this is the direction resultant is making with the vector P. Okay. Next I am discussing some points, some special cases. Okay. Let's start. Case 1. Let us suppose the vector P and Q are in a straight line and the direction is same. So P has the direction common direction. Okay, P and Q have the common direction. Okay, so the angle between them will be theta is equal to 0 degree. So R is equal to P square plus Q square plus 2PQ cos theta. Sorry, we are trying to find out the value of R, putting the value of theta is equal to 0 degree. So here P square plus Q square plus 2PQ, this will be cos 0 degree. What is cos 0 degree? Cos 0 degree is equal to 1. So the whole expression becomes now what is P square plus Q square plus 2PQ? This is equal to P plus Q whole square. But again there is a power, half power outside. So the whole expression becomes P plus Q. So the expression becomes R is equal to P plus Q. So if there are two vectors, they have a common direction, they are moving in the, they are acting in the same direction. In that condition only we just add the vectors magnitude to find out the resultant R. The next case is case 2. The next case is what will be the value when theta is equal to 180 degree. So if the theta is equal to 180 degree, suppose P is acting in this direction, so Q must be acting on this direction, just opposite of P, and the angle will be equal to 180 degree. So trying to putting the value of theta, P square plus Q square 2PQ cos theta, theta that is cos 180 degree. What is the value of cos 180 degree? This is equal to minus 1. So the whole expression reduces to P minus Q square. So R will be equal to P minus Q. So if the two vectors are acting in opposite direction, we just subtract the bigger vector with the smaller vector to find out the value of resultant. and the resultant will have a direction. Okay, resultant will have a direction as same as the direction of the bigger vector. Okay, now next is case 3. Case 3 is when theta is equal to 90 degree. So in this condition, let us suppose P is acting in east direction and Q is acting in north direction, completing the parallelogram. So this will be the diagonal and this will be the value of R. Okay, so R square is equal to P square plus Q square plus 2PQ. In place of theta I am putting the value of 90 degree. Now cos 90 is equal to 0 degree. So the whole expression reduces to P square plus Q square. So R is equal to under root P square plus Q square. So this is equal to under root P square plus Q square, and the angle alpha will be equal to tan alpha is equal to, from the figure we are finding that this is Q and this is P. So alpha will be equal to perpendicular y base, that is perpendicular Q base, that is P. So alpha will be equal to tan inverse Q by P. So there are 3 cases, case 1, case 2 and case 3. Let us take one example, one numerical example concerned with the formula R square is equal to P square plus Q square plus 2PQ cos theta. Okay. Suppose there is a problem 1. In this problem, P is equal to Q. P has the same magnitude as the Q, magnitude of Q, and the resultant also have the same magnitude. Okay, but the direction of P is not the direction of Q. Okay, because in that case it will be equal. We are to find out the value of theta, the angle between P and Q. Okay, so let us start. First we know we will write the formula R square is equal to P square plus Q square plus 2PQ cos theta. Now we know very well that P is equal to Q is equal to R. So trying to put the same value, okay, not different value P and Q R, we are putting the same value. So R can be replaced by P square, R square can be replaced by P square, Q can be replaced by P. So here we can also write like this one. So I am converting the expression into P. Okay, so this will be equal to P square, this will be equal to 2P square cos theta. Taking the common, 2P square will be common there. This P square will cut this P square. So the expression becomes 1 by 2 is equal to 1 plus cos theta. So cos theta will be equal to minus 1 plus 1 by 2 is equal to cos theta. So cos theta will be equal to minus half. Now here the value of theta for which the value of cos theta is minus 1 by 2 is 120 degree. So we can write here cos 120 degree is equal to cos theta. So theta is equal to 120 degree. Okay. Hope you will like my video. Okay, and please share this video with your friend, and just subscribe it. Thank you.